All right, welcome to the Marine Amateur Radio Club. This is our first deep dive session on AREDN, and nice to see a big group of operators here tonight. Um, we are going to talk about AREDN and what it is and what it's all about and why we care. And we'll also do some demos at the end. I don't know if I'm going to be able to get the demos on the recording or on the Zoom, so you guys on the Zoom may miss out on the demos because when I was trying to bring my network connection up, it took away my Wi-Fi and the Zoom dropped out. So we'll have to play that by ear. But the people in the room will be able to see the demos and we'll go from there. All right. So what is AREDN? What it is AREDN stands for the Amateur Radio Emergency Data Network. It's a mesh network. It operates on under amateur radio frequency under Part 97 rules, and it uses repurposed wireless ISP grade hardware and uses a custom firmware installed on that hardware. So when I'm talking about wireless ISP hardware, I'm talking about things like this gizmo here. This is a MikroTik SXT, and these are like, what are these, Paul? $50, $55, something like that.
Something like that.
Yeah, so it's really not expensive to get into this game. It can get more expensive if you want it to, but it's not too expensive to get started in it. I've got a couple of other examples I will show in the demo portion, and Jeff brought some gear as well. So,
And please be careful the way that these dishes are pointing.
yes,
I know Neil.
this is not powered, so
He came in with a full head of hair, and then he sat there. Yeah, turned that on, and look what happened. I know.
so you'll notice
I know.
this one, I don't have the dish attached to it, and it's just pointing off to the side. So
Did you change the power level?
I didn't touch anything else on it. I haven't even turned it on since we programmed them. So we'll see how it is when I get to the demo. But I could turn the power way down too. I did have some custom stickers made up that said warning RF radiation, stay back 5 feet, because my setup at home is at ground level and I didn't want neighborhood kids walking over and monkeying with it. So I figured I'd scare them off that way. I don't think it's necessarily dangerous as long as you're not physically touching the front of the horn. But yeah, right. Don't lick. Do not lick. I should put that on the sticker. Do not lick. Right. Yeah. We when I worked at Raytheon, we had a key hanging in our computer room. Nobody knew what this key was for, but it was on a wooden like key fob thing, and on the key fob it said emergency key, do not lick. And I don't know why, but nobody knew what that key was for, but it hung there for the 6 years that I worked there. So no,
What did it taste like?
that I do not know. I did not lick it. So yeah. Okay, so what's a mesh network? Well, networks in general can have various topologies. Okay, you can have what they call a bus technology. This is like a old style Ethernet cable is a bus technology. It's a long cable with a terminator at each end, and you have stations attached to it. Each of these stations is sharing access to this cable, so it uses a protocol called CDMA, Carrier Detect Multi-Access. And so when a unit on the cable wants to talk, it listens first to hear if there's a carrier. If it doesn't detect any carrier, then it asserts a carrier, waits a little period of time, and then sends its data. The waiting time is to allow that carrier to propagate to the end of the cable, and so that other stations will know it's there. If a station is listening, turns on its carrier, and hears another carrier at the same time, it'll cause some interference, and that's a collision detection. And so both nodes will detect that, and they'll back off a random amount and try again. So it's basically, you can consider this as a single network cable. Now, traditional packet radio uses this kind of technology. It's all running on the same frequency, on the same airspace, but it's a little different because with packet radio, node A might not be able to hear node F. And so they could both transmit at the same time and talk to nodes that are near them, even though they're on the same frequency. So that's something that is a little bit different with packet radio versus this, but the technology and the terminology is kind of the same, where You're all on the same frequency. You want to transmit, you listen first. If nobody's using it, you transmit. If you detect that there was a collision, you back off and retry. Okay. So that's the bus technology.
It's different from family communications where it's only collision detection. There is no listening first.
That's right. There's no listening at all in family communications. So in my experience anyway. Another technology you might see is a ring network. And there are a couple of different examples of this: token ring and FDDI, fiber distributed data interface. What happens here is these nodes are connected in a circular fashion. So each node has two connections. Sometimes they have dual cables so the ring can go in both directions, right? But there's a token or a particular packet that propagates around the ring, and you can't transmit your data until you see that token. So if you see data come in on your input interface, you send it out the other interface unless it's for you. And so it propagates around the ring. And when the token comes to you, then you send your data and then you send the token on to the next node. And the data just kind of moves around. And each node that wants that data picks it off the ring, and then they pass the token on to the next guy. So one node is able to send its new data at any time, but all the nodes are basically receiving and transmitting all the time. There are the problem with this, of course, is if somebody snips one of those cables, everything's dead, right? Because the token won't go past that point, and so everything dies. But there are technologies with what they call a dual ring, where one ring is going in one direction and the other ring's going in the other direction. And if a node detects that the cable has broken, it can send it back on the return link. So it makes kind of like a C, and then it goes back around the other side of the C, and it'll just go around and around like that. So it'll evade those breaks. It won't handle two breaks. With two breaks, you'll get two separate networks. They'll both work, but they'll be separate. So I think the only things that really used token ring networks that I remember was the Apollo domain system and IBM's mainframe stuff. The mainframe stuff used token ring on all of its networking.
FDDI is used all over the place.
FDDI was used a lot. FDDI is basically a fiber communications network, and it was used in a lot of places. All right, star network. You basically have one box at the middle of the network, and all the nodes are connected to that box. So you can think of your traditional Ethernet that you might have at home, where you've got a switch or a hub, and all of your computers are plugged into it. Some of those, depending on the nature of the device in the center, can only handle one machine transmitting at a time, and it looks like a bus network as far as everything is concerned, even though physically it's a star. Others with smarter switches can actually handle multiple conversations happening at the same time, and data will only go out on the ports that it needs to go out on, depending on where it's going. So it depends on if you've got a hub environment or a switched environment, and you can connect those together, right? So you could have one switch talking to another switch, and so data would move between them, and the two switches would know what nodes are on one side, what nodes are on the other side, and be able to route that data. Think of this kind of like a traditional ham radio repeater. One person transmits, it gets sent out on the star to all the other people listening, right? If somebody else transmits, everybody gets that. Only one can transmit really at a time, right? And then there's a mesh technology. And in this diagram, you see a completely connected mesh. So every node is connected to every other node. The great thing about this is if I want to send data to another machine, I have a direct connection to that machine. I can send it. No problem. There's nothing getting in my way. I don't have to worry about any collisions, anything like that. This kind of technology is what we call a mesh. Mesh networks allow dynamic reconfiguration of the network. So new nodes can join the network or nodes can leave the network, and the network will figure it out. The difference between a full mesh and a partial mesh is in the partial mesh, every node doesn't talk to every other node, but nodes can talk to multiple nodes. Okay. So if you look at this diagram on the right, let's call that top node node A, and the bottom node D. So if I want to get a packet from A to D, I can go to C and then to D, or I can go to F and then to D directly. Now, if I was going to send to B to D from A and node C was down, I could still get there by going to node F and come down that way. And if for some reason that link between F and D went away, I could go to F and then to E and then to D and still get my data through. So the objective here is this kind of automatic recovery from missing node problems or bad link problems or things like that. And each node will figure out the best way to get to the other nodes in the network. What we're talking about with AREDN is going to be a mesh network, which is this type of network, where the nodes use a protocol to decide which other nodes are around, and they send the data in the way that makes it get where it wants to go most efficiently. Okay. All right. There's other technologies, point to point, which would basically be two nodes. They talk to each other, only each other. If you remember the old BBS days when you would dial up to a BBS, you would have a point to point connection between you and the BBS using your modem on the phone, right? Well, sorry, I just dated myself there. But we used to use UUCP to transfer our email when I worked at Olympus Software. We had a UUCP connection to a company called Keiko, and they had a connection to the U of U. And so we could get out to the rest of the world by sending our data to Keiko. They would send it to the U, and then it would go out on the internet from there. The key factor there is only those two nodes could talk to each other, right? They can't talk to anybody else directly. A tree network would be where you've got one node that's connected to other nodes in a one-to-many type of relationship. So think of like they call it a tree, but they always draw it upside down. So it's more like you're thinking of the root system of the tree, not the branches of the tree, the way we visualize it in networking. So an example of that would be like a call tree. If you had a call tree for your organization, you might be the guy who generates the message, and you're going to call three people, and each one of them is going to call three people, and each one of them is going to call three people. And with you only making 3 phone calls, you've reached 27 people or however many, right? So, that's kind of the idea. And then hybrid networks are combinations of 2 or more of these network technologies. And you have nodes that are called gateways that bridge between those different network types. So a node might be on a bus network or a star network at home and also be on a mesh network where it can move things out on the mesh. And other nodes that are on this home network can get access to the mesh by going through that gateway. Okay. So that's the basics. All right. So what does this look like in the real world? This is a picture of Murray as I've proposed a AREDN deployment here. And with this setup that you see here, I have let me see if I can turn pointer on, if I can get to it, if it will let me. Well, it won't work on the TVs.
It'll work on one of them.
Yeah.
And we'll be like cats,
Yeah.
Let's see if this works.
Yeah, we'll work to the Zoom here.
Spotlight. Okay. There's my little red. Do you see my little red guy? You guys online at least. So you'll see here in the middle, this is the animal shelter where our repeater is. And we have that 200-foot tower there. So the concept would be you put some nodes on that tower and they would be able to maintain links out to other places. Dan's got his hand up. Go ahead, Dan.
What do they call it, the animal shelter? Because there's a big furnace there.
Not all animals make it through the shelter. Yes. So.
Okay, sorry, I digress. I couldn't resist.
It was animal smelter in this film.
Yes, right. I'm sorry for Dan, but okay.
Oh, you're recording, sorry.
Yes, I am recording. So I also have on here a node at each fire station. So up here at the top is fire station 81. That's where we are right now. And then way over here on the east side is fire station 82. And then over here is fire station 83. And so you can see I've got direct links from here to each of those stations. And then I've also put nodes at each of the elementary schools in town. And you can see we've got pretty good coverage of the city. Kind of this area may suffer a little bit because there's not any real stuff in the middle here. But if we were to work out some arrangement with IMC to put something on their building, which is right here, that would probably do some amazing things. But so the concept is that these network links would be available. And if any one of these schools dropped off or even the center tower dropped off, there are enough backup connections that this mesh would stay up and those would be able to talk to each other. Okay. And so you as a user, maybe you're living right here, for example, and it's closest for you to hit McMillan. So you would point your little SXT at McMillan and you'd be on the mesh. Okay. And if McMillan went away, you might aim this over at the tower. Or if you had to go to the park for some reason, you could point this at the tower or at one of the fire stations that are around. The idea being that you could join the network from anywhere in the city. Okay.
So all these points are gonna have several of these directional antennas, basically, or
We'll talk about that in a sec. You had a question.
Okay, yeah, so all this is on the internet, is that correct?
This is not on the internet. This is completely separate from the internet. So the objective is that this is a standalone network available for passing traffic, amateur radio traffic, and potentially emergency services traffic.
It's called an intranet, where it's
a private network.
type of technology, but it's not connected to the World Wide Web. It is enclosed.
Now,
They call it intranet.
we could put an internet gateway on this network so that if you were on the mesh, you could access the internet. But you got to keep in mind on amateur radio frequencies, no encryption. So don't go to your bank on this network, right? Don't use your web browser and go to your bank, even if you've got a connection to the internet. There are ways to make that work. We'll talk about that in a later deep dive. I've got a deep dive planned in a couple of months on applications for the mesh, but that's out of scope for this meeting today. But yeah, so the idea is that this network would be able to be up and operating even if the internet was not, and it would allow high-speed connectivity within the city without the internet being up. Okay, so this, let's see. Let me put this away. Okay, so just to get everybody on the same page with terminology, I've got some definitions to go over. So these are kind of the key words that you use in describing parts of this functionality. Okay, so I call a site the physical location where any equipment is. Okay, so for example, the tower would be a site. It might have 3 radios there, but it's going to be one site. Okay. A node is a piece of hardware or a virtual machine running the AREDN software. So this would be a node. Okay. Possibly at my house, possibly in my Go kit or wherever, right? I've got a MikroTik LDF5 at home already, so I already have a node at home. But yeah, I could set this up and point it in a different direction from my LDF5 and bridge 2 parts of the mesh to each other if I needed to do that. The interface is either an RF interface, a radio interface, or an Ethernet connection. So if you look on this guy, you can see it has an Ethernet jack on it. So the way these things connect to other physical devices is via Ethernet. So just like your network at home that you would plug your computer into, right? A port is the physical jack. So I differentiate between interfaces and ports because multiple interfaces can use the same port. I might have one interface on one network and another interface on a different network, all going through that single port. We'll talk more about that in a minute. A tunnel would be a connection between 2 nodes on some other network. So like a VPN or something, or over the internet. So if I don't have an RF connection between 2 nodes, I can still connect them together using another network mechanism. Whether, that could be even packet radio network. It would be really slow, but you could do that. You could make that work. Or it could be a tunnel over the internet, which is great when the internet's up, but of course that link is going to go away if the internet fails, right? So you don't, that would be something you wouldn't want to depend on, but you could use it in testing or validation of things or working out how services work and stuff like that. The mesh is the overall interconnections between all the nodes. Okay. So all of these nodes, these pieces of hardware are all connected together, and all together they form this mesh. And then a LAN or a local area network would be something that is attached to one of these nodes that hosts local resources. For example, if I were to plug my computer into this Ethernet port, my computer is now on the LAN side of this device. Okay. So I would plug, well, technically I would plug this into a switch, and then I could plug a computer or a camera or, some other device into that switch, and it would be on the LAN side of this. So it would be able to access things on the mesh, and the mesh could access it, but it's not a mesh node itself. So it's not a node, it's just a host on the network. Yeah.
Sorry, I got another question.
Yeah.
Okay, how much power does that require?
This thing,
Yeah,
this one runs on 24 volts and it draws, what do these draw, Jeff? 1.2 amps or something like that?
That's, they'll run on anything from 10 to 28 volts. Running on 12 volts, I measured mine at 150 milliamps, so 0.15.
So half an amp,
No, an eighth of an amp.
eighth of an amp.
Yeah.
So Paul says he's tested this on his, and the node itself will run on an eighth of an amp, anywhere between 10 and 28 volts. So it's pretty flexible. Another question. Yes, they do support PoE. We'll talk about that when we get to the demo port. In fact, PoE is on the next screen, but the last one on this screen is DTD, which are device-to-device links. So this would be a wired connection between multiple nodes. So for example, say I was on that tower and I had 3 nodes with sector antennas that each cover 120 degrees of the valley. I wouldn't want those nodes to have to talk to each other over RF when I have them all physically at the same site. So I could hook them all together to a switch, and they would use a DTD link to talk to each other directly. So that's what DTD means, is device to device, and it refers to nodes, node to node. Services are the servers and resources that are available on the mesh. And there's a ton of things, anything you can do on the internet, you can do on the mesh network. Okay. So email service, WinLink, video cameras, voice over IP, repeater links. I know Paul's been experimenting with running a repeater link over this type of a network. You can do text chat, screen mirroring, remote machine access, all this kind of, anything you can do on the internet, you can do on this mesh network. It's just like your own private internet. Okay. PoE is power over Ethernet. That's a way to bring both power and Ethernet to a node on a single cable. So you see this thing only has one jack on it. There's no separate power jack on this. So it's expecting to get its power over Ethernet, and it comes with a little gizmo that looks like this, that I plug. This goes into a network device. This goes to the power brick, and then this goes to the node, and I have power going over the cable. So this could be in my house. This could be on the roof, 100 yards away, and it works just fine. It would
So
be able
just
to.
so everybody knows how Ethernet works, right? You have a 8-conductor cable, RJ45. The first 2 is your receive pair, then pin 3 and 6 is a transmit pair. And that's your data. Because we still have 4 pins to work with, they put power on, I don't know if it's 4 or 5 or 7 or 8.
It's both.
That's both of them.
It'll actually use both. And in fact, there are some
pairs. For power?
Yeah, there are some protocols that will actually run power on the data pairs as well.
Okay,
So
Gig Ethernet uses all four of the pairs.
Say again?
Gigabit Ethernet. and high-
Gigabit Ethernet, yeah, this doesn't work for gigabit Ethernet.
gigabit works
Well,
with PoE,
they
so
do things different.
yes,
though,
yes.
but
This is just a basic idea of how
That's the
PoE
basic
works.
idea, yeah, this is how we can use existing technology for other stuff. So this is a typical PoE, power over Ethernet connection.
So you might already have an Ethernet cable in your wall, for example. You can run the power over that without having to run separate power to your device. Okay. A VLAN is what they call a virtual LAN. That's a tagging mechanism to allow multiple networks to run on the same physical connection. Remember, I said you could have multiple interfaces attached to the same port, the same physical network port on your device. The way you do that is with VLANs. So one network, one interface for a particular network would be on VLAN, say 2, and the other one would be on VLAN 3. So they can both run on that same physical connection, that same cable, but you're able to run multiple networks over that. That's how the DTD traffic is separated from the LAN traffic. The LAN is going to be on one VLAN. The DTD is going to be on a separate VLAN. Okay. A switch is a hardware device that multiple Ethernet cables can be connected to. Pretty much everybody has seen a switch if you've got any kind of networking going on at home. There are PoE switches that have PoE built into them as well. Most of these devices are passive PoE. So if your switch does protocol specific PoE where it requires connectivity with the device, there's a protocol called LLDM or something like that that it uses to communicate with the device and figure out what it's capable of. That's not going to work with these. You need something that can give you that 24 volts of power on your PoE without the node asking for it specifically. There are PoE switches available that can do that as well. Some of them, you can tell them to run in either mode, and they will run a particular port in any mode that you tell it to. Not all of them will do that. And then a gateway is a node, like we talked about before, that is connected to both the mesh and another network. So, for example, the internet. You might have a node that's on the internet and also on the mesh, and it can act as a gateway for traffic going between the two. Okay. Let's talk about AREDN compatible. Did I miss a slide? Let me see. No, I don't think so. I'll have to find that other slide. I had another slide that showed some network coverage stuff, but I don't remember if I have that later in the presentation or if it's in a different presentation. I'll have to look and see. Well, if we get to the end of this without seeing it, I'll pull it out and we can look at it. All right. So one thing to note, the AREDN software doesn't run on all wireless ISP equipment. Okay. You have to be careful what's hardware you buy to run this. You want to make sure it's compatible. Right now, AREDN is supported on 4 different brands of equipment: Ubiquiti, MikroTik, GL-iNet, and TP-Link. Now, TP-Link is going through some crazy stuff right now where they're trying to actually ban its use in the US. So the government thinks that it's bad for some reason.
Chinese.
Yeah, because it's from China. And so they think that the Chinese are putting stuff in there that they don't want to be in there. And it wouldn't be a big issue for us because we're going to throw away any software that's running on there already and put our own on. But if you can't buy the hardware because it's banned, then that's off the table, right? This gizmo is from MikroTik, which these are actually Ukrainian or Russian? Latvian. So a former SSR. But yeah, these ones are still fully available. And then these guys, well, like this one here is Ubiquiti. Okay. I don't have any GL-iNet gear to show, but you can get GL-iNet gear as well. Yes.
People notice is if you buy a piece of ask them, is it supported? It will show up. Even though it's not.
You may get different answers depending on if it's supported for real or not. I highly recommend checking the supported devices list. There is an actual list online, and this is the link to it, before you buy something. I know, I know people who have bought hardware hoping that it would work, and it almost works, but it doesn't quite work. And that is extremely frustrating when you run into a situation like that.
And ubiquity.
Yeah, Ubiquity is known for that.
However, this dish and another smaller rectangular lighter weight dish, we both recently bought a lot of 34 of them surplus from a Wi-Fi company. Or an ISP service provider.
Yep,
For $20 a
for
day.
$20 a pop. So, you know,
So, time it right.
yeah, you can find the gear. You just have to be observant. But don't just buy whatever. Let's make sure that it's actually going to work first. So radio hardware prices range from 35 to 200 for new. Again, like Paul said, this we got for $20 used, right? This was used in a wireless ISP network for probably 3 or 4 years, and they upgraded to new hardware, and they have a huge pile of this stuff that they're getting rid of. The guy advertised it on KSL, and you could pick it up from there with, 20, drive down to, was it Ephraim? Drive down to Ephraim and pick up a bucket full of them, right? So $20 a pop. Same thing with the power beam or the light beam. I'll show you later. But what I've got on this slide, you can see on the top, there's a MikroTik HAP. That is a node that has both a 5 gigahertz and a 2.4 gigahertz. Paul's got one right there, network on it. And it also has 5 Ethernet jacks. And those Ethernet jacks, one of them will do the passive PoE. So you could plug another device into that directly and not have to use a separate PoE injector for that. The 3 of them are LAN ports, and the other one is designated as a wide area network port. You would plug that into your home network if you wanted to do that. You can control what gets access to your home network through this and what doesn't. So it's not necessarily dangerous to do that. Another question.
And don't buy the one with 5
Which one is that? That's the H.
looks exactly like that, except all the ports are,
Really? Is it an AX device or an AC device?
I think it's an AP, but those dots.
Huh. Interesting. Okay. I know there's 3 different versions of this. There's this one, and then there's the HAP2 and the HAP3, and they all have different capabilities. The 3 actually has 5 network ports, and you can decide if the port is going to be a DTD port, a LAN port, or a WAN port yourself. You can actually control that in the software. The 2 doesn't let you do that. It's more like this one, but it has some other feature that the other ones don't. And one of them, I think the 3 has a USB port on it as well. So you could plug a USB device into it. I think, Jeff, didn't you have one of the HAP3s and you plugged your GPS into it?
Yeah.
Yeah, you got it over there? Okay. So Jeff's got one of those over there. So antennas, you can either use an omnidirectional antenna or you can use a directional antenna. Omnidirectional antennas are like these examples here. The idea being that this antenna works in a 360 pattern around the site, right? Directional antennas, there's a sector antenna like these. They will cover, I've seen them with a 90-degree coverage, and I've seen them with 120-degree coverage. So with 120 degrees, 3 of them will cover a full circle. With 90 degrees, 4 of them will cover a full circle. There's a limitation on these versus the omnis because as you bring that signal in, it also comes in this way. And so your direction matters more where you're facing this thing, right? So you need to be aware of that as you're positioning this antenna. I know, who was it? Who's got a Scott has one of these.
K7HSR.
Yeah, up in the avenues, and he's got it kind of pointed out at the valley, but he had to kind of monkey around with the angle before it would actually be visible to people down on the ground, right? So, um, and then of course you can use some kind of a beam or directional antenna like a dish or a Yagi or one of these kind of antennas that is much more directional, gives your power much more focus, makes your coverage much less. So your aim needs to be more specific. These ones, what are these? These are like 9 degrees or something like that.
Those are
15 degrees.
23 or 27.
23 or 27 degrees for the SXTs. I know the LDF that I have actually hooks onto a surplus dish TV dish. It replaces the LNB on that, and you can get quite a bit of gain out of that. But again, it does narrow your beam width down significantly when you do that. And it's much harder to aim, yes. The problem with the dish network, those antennas, if you had the antenna sitting like this, the aim point is actually that way because it's designed to aim at a satellite. So you have to point it almost at the ground to actually get a straight out connection. So it's something to consider if you're going that route. It can be a little confusing when you're setting it up and you're like, why do I have this thing pointed at the ground? Well, you don't really. It's because of the placement of the node versus where the antenna is facing and how the reflection pattern works and all of that. So all things to consider. All right, so once you have the right equipment, then you have to look at the software. So these devices by default ship with software that is manufacturer dependent. So Microtech ships with their Microtech software. Ubiquiti has their Ubiquiti software. All of those software systems are based on OpenWRT. And that's why AREDN is able to do this, is because it's also based on OpenWRT. There are some versions of OpenWRT that are not supported by AREDN, and so that's why there's some of this hardware that doesn't work. Okay. OpenWRT is an open source project. It's under continual development. Now, the individual vendors are going to put their own web interface on the front of this thing. They're going to put their own configurations and stuff. So how you do things is different depending on who made the device. But the process is essentially the same. What the AREDN software is its own control panel and configuration interface. It adds the OLSR routing software that lets you do the mesh network and enables the use of frequencies and power levels that are outside of the Part 15 restrictions. Because remember, Wi-Fi normally runs on Part 15 rules, but we want to run under Part 97, which gives us extra frequencies that we can access and also allows us to kick the power up more. Okay.
Is all of this wireless ISP stuff, is it all Wi-Fi or do they have?
It's all Wi-Fi. It's all
They don't
Wi-Fi.
use other bands for like transmitting
No,
fixed wireless?
No. It's all Wi-Fi. It's either 2.4 gigahertz or 5.8 gigahertz. There was a 3.6 gigahertz that you could get. You can't get that anymore because the FCC decided to sell that to some cell phone carrier. So we can't use that anymore. But yeah, 2.4 or 5.8, they're highly unlikely to be able to sell those frequencies because there's so much Wi-Fi deployed out there already. Okay, so what you have to do is you have to install the software on the device. And we call that flashing it. We call it the firmware for the device. It's not really firmware. It's really just software, but we call it firmware because you're thinking of it as a device. And so the stuff that's running on the device, you're going to call firmware. And that software on there is stored in flash memory. So we call it flashing when you replace the software that's on there with your own software. Okay. Each manufacturer has different ways of doing this. For example, with Ubiquiti hardware, you run a TFTP server on your with Ubiquiti, a TFTP server runs on the device, and you hold the button down when you power it up to make it go into this mode, and then you use and then you use a TFTP client. TFTP is the Trivial File Transfer Protocol. It's often used for things like booting over the network. You use a TFTP client to push the new image to the device. With Microtech and TP-Link hardware, it wants to boot from a machine using a protocol called PXE, a pre-boot execution environment. And so you run a PXE boot server on your machine, And then you boot this up holding the reset button down in a particular pattern, and it will come up and look on the network to see what it can find. And if it finds a Pixie boot server, it will pull an image from that and use it. So you can do that to install out a MikroTik and GP-Link. GL hardware, you can go into their own web interface and they just let you upload whatever software you want. They don't care. It doesn't like Ubiquiti. If you tried to do an upgrade on Ubiquiti to an AREDN software build, it would say, that's not a Ubiquiti software build. I'm not going to let you do that. Same thing with MikroTik. It's going to say, that's not a MikroTik software build. I'm not going to let you do that. But GL iNet software systems say, sure, give me whatever you got. I don't care. I'll run it, whatever. It'll be fine. Right. So that's probably the easiest ones to do. Yeah.
That reset button,
Yeah.
had several older ones that people have tried to flash, and the reset buttons are all broken off.
So the comment.
Because it's a purpose. It's a junk.
Yeah. The comment is that on some old used hardware, the reset button is broken, and that makes it much harder to flash. So, be advised if you get something and it doesn't seem to work, don't try pushing the button harder, hoping that that will help. But you might have to open it up and take a look at it and maybe resolder that. There's surface mount components on there, and so, it can very easily get pushed to the point that it breaks loose from the board, and that would be detrimental to making your device do what you want it to do.
On the Ubiquiti ones,
Yeah.
the little power supply has a reset.
Oh, yes, that's correct. Let me see. I have one of those. So on the Ubiquiti, this is the PoE injector, and this one on here. Let's see, does this one have it? I don't see it. Oh, yeah. There's a tiny little reset hole on the power adapter that you can push. And it sends some kind of pulsy signal over the PoE to the device that sets it into this reset mode. So even if you have it mounted on the roof, you don't have to climb up on the roof and find the reset button on the device. You can do it from the power injector for the PoE, which is kind of cool. Ubiquiti, as far as I know, is the only ones that do that. Next month, we will do some installations. We'll have a hands-on installation event. So if you want to play and you want to get some hardware, get it before next month and bring it, and we'll do it. We'll do the installs and we'll make it happen. We went over to Paul's house a few months ago and flashed. How many did we do, Paul? 34 of these things. So in the course of about 3.5, 4 hours, we had 4 people doing it, and we flashed 34 of these devices, and we got it pretty much down to a science, where we had it down to, like, it was taking them about 10 minutes per at the end. But the first one took like an hour because we had to figure out what we were doing. But yeah, so those were all Ubiquiti devices. They were light beam and power beam devices, and we did 34 of them in an evening. And it was some of us were a little punchy at the end of that, but it was fun. It was fun to do that. So next month we'll be doing that. Once installed, you configure the node over a web interface. So you'll connect to the web interface on the node, and it'll look something like this. This is what my HAP looks like at home. So I have an HAP sitting at home that is on the WAN port is attached to my home network. The PoE port is attached to my LDF5. And you can see on here, let me get that pointer back again. Spotlight. So you can see here, this is the node description. It's HAP at KD7ZWV home QTH. At the time, it had been up for 23 hours and 5 minutes. Oh, no, it had been up for 58 days and 20 minutes. The time of day was 23:05. This is the load average, or the busyness of the CPU on the device. This is how much free memory it had and free flash that it had. And this was the version that it's running here. These are internal services that are running on the node itself. And then any local services you can also access through here. This does not show the LDF5 is I don't think I had the LDF5 hooked up at the time. Oh, no, sorry. It would have been down here below the screen. The local devices would be like if I had a phone attached to it or if I had a camera attached to it or something like that. And I did not at the time. And then this describes what the device is. It's a Microtik router board, HAP AC Lite. And that's, I guess, the serial number. And then it was on the LAN was on channel 149 and presents itself as KD7ZWV-AREDN is the SSID. The mesh, I don't have the mesh radios turned on this device. So because it's in my basement, there's nothing that I can really talk to on the mesh directly.
So that's why I pulled up in your driveway and it wouldn't work.
But it knows there are two nodes because this is one of the nodes and the other node is my LDF5 and 4 devices associated that it knows. One of those would be the phone, one of those would be the computer that was not connected to it at the time the screenshot was taken. But yeah, so you can see how this works. Some hardware has multiple radio interfaces. You can configure them for different purposes. You can have one interface be the mesh, the other interface be a LAN. In general, you can only have one interface be on the mesh. So if it had 3 interfaces, you couldn't have 2 on the mesh. You could have 1 on the mesh and 2 on the LAN, but not 3 on the mesh or 2 on the mesh. Some hardware has multiple Ethernet jacks, like we talked about. The HAPs have multiple Ethernet jacks. You can configure those for different reasons, different purposes. Let me put this back away. Some settings require specific configuration depending on the network you want to join. So these use the ad hoc Wi-Fi protocol. So normally when you're at home, you're using a client server Wi-Fi connection, or like if you're at a internet cafe or a coffee shop or something like that, and you're connecting to their Wi-Fi, you're using a client server connection, in which case one device is the server and the other devices are clients that connect to it. In this case, the devices are using an ad hoc network, so they're all both servers and clients to each other. But you have to make sure you're all on the same channel, or else they're not going to talk to each other. The bandwidth of those channels has to be set to the same. So AREDN supports 5 megahertz bandwidth, 10 megahertz, and 20 megahertz. We've been mostly running with 10 megahertz in our testing. But the idea being, if you use a narrower bandwidth, you get more power over that connection. So you might get a better connection, get more signal through. You can pump less data through it, but you got a better chance of getting a farther distance or something like that. If you use a wider bandwidth, like the 20 megahertz, you can pump a lot more data through it, but your connection has to be much stronger. Okay. And the signal to noise ratio is critical in network design. We will be doing a workshop on network planning and design. So that will be coming, I think, in 2 months. We'll be doing that two or three. I'll have to look at the schedule, but we will be doing a session in that during this deep dive. We will plan how we would deploy an AREDN network in the Salt Lake Valley, and we'll figure it all out together. If you're working with a group, you might want to choose the same admin password for all of your nodes so that other people can administrate your node if you're not available. Because remember, with amateur radio, an automated station, you need to have a way to be able to turn it off if it starts misbehaving, right? So if you aren't physically able to turn it off, someone else on the network could physically turn it off for you using that capability. So don't give that password to people you don't trust, obviously, but the network that we've been talking about deploying for Aries, we would use the same password across the nodes within that network. If we were to deploy a network in Murray, we would use the same password on the main nodes within that network. Your own individual nodes, you could use your own password for whatever you're doing, because we wouldn't normally touch your individual stuff. Okay, frequencies. So if you look at the 2.4 gigahertz and the 5.8 gigahertz Wi-Fi bands, you will note that in Wi-Fi, there's a bunch of channels, 1, 2, 3, 4, 5. There's also some negative channels that are not allowed to be used by Part 15 Wi-Fi, but they are within the ham portion of this band. And so we can use those with no interference with any other people's Wi-Fi. If you're running on uh, channels that are one or above, you stand a chance of using the same channel as somebody else, and that will cause you unnecessary interference, right? So something to configure when you're doing your network planning is what channels do we want to use? We've been doing mostly 5.8 gigahertz networking. We have talked about doing some 2.4 for specific links that maybe longer shots and things like that, where the 5.8 is not getting through. So we may explore that. I don't know where we're going to go with that. Paul might have some ideas, but we haven't done a lot of talking since the last exercise in November. So
I think everybody's kind of burned out that.
yeah, I think everybody was pretty beat with the whole thing, and we kind of let it slide for a little while. It's starting to heat up again now. We'll probably start digging into it some more. There's been a lot of talk on Meshtastic lately, which has been kind of interesting, but Meshtastic feels more like a toy than a tool at this point. So I don't know. We'll see where that ends up. But and then on the 5.8 gigahertz, uh, we can use the whole frequency range from 133 up to 184. Now, the normal Wi-Fi is using 133 to what is it, 175, 176-ish. And this is also shared with ISM. It's also shared with, what is the other one?
180 through 184 are shared with intelligent transportation systems.
Intelligent transportation
That's
system.
all the data that flows from traffic signals
And like railroad stuff and things like that, right? So be aware of that. You know, we're a secondary user on that, right? So you need to be careful you're not doing something that's going to screw up the traffic signals. Not that anyone would know it's you, but you know, if you're um, hearing a lot of honking, maybe turn your thing off, change the channel. I don't know. Anyway, so
It seems like that'd be difficult because there's traffic signals everywhere. Right?
keep in mind that these things use spread spectrum. So if I switch to channel 2, for example, on the 2.4, I'm actually overlapping into channel 1 and channel 3. And my signal is kind of bouncing around within this range. So it's not just like a VHF signal, right? These are using a spread spectrum technology, and so they can interoperate with other signals, and they do. Yeah.
actually, Wi-Fi and AREDN are not spread spectrum technically. There's a bunch of carriers within a bandwidth, but they're not jumping around.
Oh, okay. So
But that means that ITS, which is spread spectrum, can't hear us and we can't hear them to even know where they're.
gotcha.
Oh, so that's how.
So that could be an issue, right? So Paul points out that AREDN and Wi-Fi do not use spread spectrum. They use channelized access within this band. And so we need to be aware of other users of the band that may be using spread spectrum and not, that may be affected by us or not affected by us, depending. So it's something to think about.
It'd probably be pretty hard to take them out unless you're really.
It would be hard to affect them, really. But you know, just because it's hard doesn't mean we're not going to do it. But anyway, this networking, because it's in the microwave bands, it's only line of sight, right? There's no ionospheric bounce or anything like that you could take advantage of. And the rule of thumb that people have been using, I've heard this, is a Wi-Fi signal can go 90 miles or through one tree. So my house is surrounded by trees, and which really impacts what I can see and what I can access. And so I've got right now, like I said, I have my LDF5 at ground level, so it's pointing out underneath the tree, trying to point out into the rest of the valley. But I have never been able to successfully hit another RF node with that connection. So whether it's aim is bad or there's just nobody there to reach, or I just can't reach them because where they are, I'd have to go through a building to get to them or something like that. I don't know. But one of the things that I've thought about is putting this guy on a 60-foot pole and mounting it on my roof and then rotating it around to see what I can see, right? So that's something that I've thought about trying just to see what I can get to.
Tree branches.
Right? Yeah, just put it out in the street. It'll be perfectly fine. Yeah, so yeah. So that's something to consider. Omnidirectional and sector antennas can also be used to provide more of area coverage, right? And directional antennas would be better for point-to-point links. So here's that coverage map I was talking to you about. With this setup here, this has just 3 sector antennas at the animal control building on the tower. I think I put them at 100 feet above the ground, so about halfway up the tower. And then omnidirectional antennas 20 feet above the ground at each of the fire stations. And this is the coverage that I could get from Ubiquity's coverage detecting tool. And this takes into account terrain and things like that. It doesn't take into account trees or buildings, but it does take into account terrain. Yes.
So do you have to use HeliX or use a waveguide
No.
at these frequencies?
No.
There's no coax connector. on
No.
these things.
These things just have a network connection. Everything is internal to
You
here.
don't need any cable?
Nope. Nope. Not at all. So you can see kind of you need Ethernet cable to get to it.
It
Yeah.
used to be UV.
Yeah. If you're deploying this outside, it needs to be decent cable, rated for outside deployment. So your typical trash patch cable, don't use this outside. It'll work fine for a year or two, and then it'll fall apart, and you'll find that you've got terrible things happening without you noticing, except that things stop working. All right, so what's next with AREDN? Salt Lake County Areas is also exploring AREDN right now. They are working with Intermountain Health and looking at installing nodes at each major hospital in the county. I'm working on an ARDC grant to fund an AREDN network in Murray, which I may extend that grant to cover the whole county. We'll see what works out. ARDC is amateur radio data digital cooperative. So these are the guys that run 44net. So it's a bunch of people that made a ton of money in, I think it was early Bitcoin days. And they decided that they would give that money to people who are doing cool stuff with digital communications on amateur radio. And so they take grant applications and give money away, which personally, I love people that give money away. So they're some of my favorite people. People that don't give money away are my less favorite people. But yeah, so these guys they will actually do grants to fund this kind of stuff. And the equipment's not terribly expensive. Probably the most expensive part is getting it physically deployed. Because if we want to put something on that tower, we've got to pay somebody to come and do it, right? So that's a large cost factor. These proposals include both infrastructure and amateur operator stations at QTH or GoKits. So it's not just the infrastructure, we're talking about the whole thing, right? And we're also looking at different services that can run on the network. We will do a class where we talk about flashing, we talk about network design, we'll talk about applications on the mesh, we'll talk about building GoKits and selecting hardware for that, and then whatever else we get to with AREDN in the course of this part of the deep dive series. So probably at least 3 months, maybe 4 we'll spend on this, maybe even 5. I don't know. We'll see where we end up. But at the end of the time, I would love to have people with some nodes at their homes and actually get some RF going between people. So we'll see where we end up. Yeah, exactly. We do. Okay, so for demos, these are a couple of links. If you want to look for more information on AREDN, go to aredenmesh.org. Don't go to aredenn.org. So there's some politics involved here. The original AREDN guy abandoned the project, and the other guys wanted to continue it. And so they wanted to keep using it, and he didn't want to give up the aredenn.org domain name. And so there was a major clash of personalities, and bad things happened, and the guys who were really doing something decided, you know what, we don't need you. We're going to go do our own thing, and it's aredenmesh.org. and that's where we're gonna be from now on.
Actually, stuff like that in here.
Never happens in ham radio, right? So that's, don't go to AREDN.org, go to AREDNmesh.org and you'll find the information. There's also the Salt Lake County Areas Mesh Networking mailing list. Go to groups.io/G/Salt Lake Mesh to sign up. You will need to have your call sign in your display name to get approved. Paul runs that network, so that mailing list.
Run is a loose term.
Yes, Paul facilitates the rest of us beating each other up with email on that list. So, but that's it for the presentation. We've got, what do we got? 15 minutes to do demos. We do have some gear in the room. Let me see.
Display the mesh status.
I don't know. So I tried doing that before we started and it knocked me off of the internet when I plugged in the cable. I should be able to be on both the Wi-Fi and the network at the same time, but it did not work correctly. So you guys on the Zoom, if I disappear, you'll know why. But I'm going to try and do this and we'll see what we can accomplish. So I'm going to plug this in. So again, if I disappear from the Zoom, you guys will know why. But we'll see what we can do. Okay. So my wired connection is up, and I should be able to go to local node.local.mesh. Look at that. So there's this is my node that I've got running right now. And this is a light beam, a Ubiquiti light beam. Normally that would be plugged into